Hi everyone, we continue this tutorial with a new chapter on function this time. In the previous tutorial, we had written all our code in the main part, which is actually the main function of a C program, which is a block of code that will be executed by default when we want to run a program written in C. So to avoid having all our instruction and thousands of lines inside this main, we will be able to use our functions that will allow us to split our program into lots of small parts that will have very specific actions and that will be able to call from the main block. So functions are an essential concept in programming. They exist in almost all languages and they are very useful to avoid repeating code. So we'll start with a very simple example, which is the addition function, to try to understand the principle. So here we will declare our addition function at the beginning of the program. So just there. Um, which we will then call in the main block. So just like the variables, we must first define the return type of our function. So for example, let's say that it returns integers. So here int, then our so the name of function, sure, up addition, and then I will define arguments, parameters of my function between parentheses. So let's say that it takes two parameters, which are a and b, and always start with the type. So here integer. And then I will define my instructions between brackets. So just there. And let's say it returns the addition of a and b. So return a plus b. Okay. So let's try to print the result of our addition function in the main block. So we're just going to do a printf, which is the default display function in the C language. So printf result of my addition is, and there I have to write the type of the parameter that this function will return. So here, for example, it will be %d for integers, but don't worry, we will see it later. It's a little bit tricky. So there I will return addition of, for example, 5 and 4. So here it's 9. Let's just run our program and we see that the result of my addition function is 9. So perfect. As I told you before, the main part is a function in C. It has, for example, a return type, which is integer here. So the proof is if, for example, we try to move this function at the bottom of the program. So for example, just here. Oops. Okay, and we try to execute it. We can see that the compiler tells us that at this point of the program, addition function is not defined yet. So which is logical because it is defined after the main function. So just to tell you that always define your function before the main block. So I can remove this part and we will now try to create a function that will calculate the maximum between two values. So my function will be called, for example, maximum, and it will take two parameters, a and b, as before. And at this point, um, we have defined which is called the prototype or the signature of the function. Basically, it consists of the name, the return type, and the parameters. So now I will define the body of my function between the two brackets. And as we saw the condition in the last chapter, this will be relatively quick. We just have to check if A is greater than B. So return A, otherwise return B. We can check the result of our function with a printf as usual. So the result is up. Let's see. Let's say maximum between 10 and 18, for example. Up. So the result is 18. Okay, perfect. You can notice that my function has two returns. So this is not really recommended in language C, but it works. So our function will stop executing as soon as it has met one of them. But in order to have only one of them, one of the solution here would be simply to define a variable which will that will contain the greatest number. So after doing the check here, so let's do it. So for example, my variable will be called max, and if a is greater than b, sorry, so max will be equal to a, otherwise max will be equal to b, simply up. And if for sure, do not forget to return the value of uh, max. Okay, so let's see if it changed anything on the execution. Okay, so perfect, the result is the same as before. We are now going to move to a part that is just as important as the function, which is the arrays. So arrays in C is a data structure that will allows us to store several elements of a type in a list. So for example, several integers or several floats, etc. To define an array in C, we start as usual with the type of the value it will contain. So let's say it will contain integers for this example, so int. Then we give a name to the array. So for example, like this. We'll open the brackets and specify the number of elements it will contain. So let's say we will have two elements in our array. Okay, so this line will therefore tell to C compiler to allocate two integers in memory. So let's see now how to add values to this array. To understand that, we must distinguish between two cases. At the time of the creation of the object, which is between brackets, is the number of the cells that the array will contain. And after creating it, which is in the brackets, correspond to the index of the elements in the array. So an important thing to specify is that the first index starts from 0. So if I say here, for example, that array of 0 equal to 10, my first elements in the array will be equal to 10. We can, for example, print it to be sure. So first element of my array is %d for integers, backslash n to, yeah. and just print here array of 0 to see what's the value. Up, sorry. So up, first elements of my array is 10. Okay, perfect. And let's do the same with the second value just to see what's going on. So here I'm just replacing first by second, and here 0 by 1. Perfect. So you can see that something is happening, which is a little bit strange because I didn't define a value to my second element, but it's totally normal because C compiler has automatically allocated the value to the second cell of the array. If we re-execute, you can see that the value is not the same as before, which is normal because in the main time there have been processes that have used this place in the memory. So in order to define several values at once, we can use this syntax. I'm just removing all those things up. So for example, I'm defining another array of integers, which is called tab, for example, and I'll say that it will contain 5 elements. And here I'm just saying that between brackets, my array will contain 10, 20, 30, and so on, something like this. So value between brackets will be in my array. We can, for example, try to display my value. So type of 0 and doing the same for um, all value of the array. So here it's the first, second, okay, third, the fourth up, and the fifth. So here I'm just replacing the index each time, 3, 2, and 1. And let's see the results. So okay, we see that the value of my array are correctly defined. So you can see that displaying the elements of the array one by one each time can be very complicated. That's why I suggest you to use a loop that will simplify displaying the elements of the array one by one, um, and just having one line with a print and the loop doing the job. So I'm removing all those things. So here I will define an integer initialized to 0 and saying that it is minus than size, and I will define here a variable size which will be equal to the number of elements of my array. So here I have 5 elements in my array, so I will say that size is equal to 5. Perfect. So here I'm saying that e will be increased by 1 each time. And here in the loop, I will do something like elements number. Here I will put a value. Okay, so elements number up of my array is another value. So first value will correspond to e plus 1, because don't forget that index starts to 0. So here I want that compiler display 1 and plus. So just like this, and tab of e, and let's see the result. Okay, so perfect. Value are correctly defined, so it's okay.